All right, Lear, we are moving on to our next topic, which is solving proportions when you have binomials. And this is what I warned you about, that now everything is coming together. We've learned how to do proportions, we've learned how to distribute, and we've learned how to solve for an equation. And these problems are on your test. It was one of the first problems we did, and it did not go well. So we got to pay extra attention here. So the title of your notes is Solving Proportions with Binomials. And then I need you to date them, okay? We have three definitions, just to remind you. A proportion is just a fraction equaling a fraction. Oh, except that should be a D. I apologize. That A over B equals C over D. It's just a simple fraction equaling a fraction. That's what a proportion is. We cross multiply, we solve. A binomial is when you have two terms. And that's what bi means. Bi means two. So binomial means two terms. And then now we actually are able to solve. We're not just simplifying an expression, we're solving for it. Why can we solve for it? Because we have our nice little equal sign. Okay? All right. So if you need to hit pause for you to write all the definitions, feel free to do so. But right now I'm going to erase everything. Okay? So we can get going. So I'm going to do the notes just a little differently today. We're going to put our steps over here. And then how we're doing the equations right here. Okay? All right. So what do I mean when we have a proportion with a binomial? Well, this is what one looks like. It's y minus 3 over 8 equals 3 over 4. Y minus 3 is a binomial because it has two terms. It's separated by a positive or a negative sign, even though that looks like it's raised to a power. Okay, so the first step is I want you to protect your binomial. With parentheses. So we're going to put parentheses around our binomial, and you're going to see why. Every time you say a binomial, whenever you're solving something, always protect it, because if not, things go badly. All right, after we do that, we are going to do what we've done before with proportions. We are going to cross multiply or butterfly it, whatever you want to think of it. Cross multiply, butterfly. So that means, where's the red marker? That means that 8 is going to be multiplied by 3. So I get 8 times 3 equals, and then I'm going to do 4 times this binomial. And how I write that is 4 parentheses y minus 3. And that's why I had to do the parentheses, because I have to distribute this 4 to each term. So that's what my next step is to distribute. So I get 8 times 3, which is 24. 4 times y is 4y. And 4 times negative 3 is negative 12, because a positive times a negative is a negative. Now remember, we want to get all our numbers on one side and our variables on the other. My variables are on the left, no, the right, so sorry, the variable's on the right. So he's already by himself. So I'm going to add 12 to both sides. And that gives me 36 equals 4y. How do I get rid of that 4? What's bothering it, or what's bothering the y, is the 4. Well, remember, it's 4 times y. So we're going to do the opposite. We're going to divide both sides by 4. Well, 36 divided by 4 is 9. So I get 9 equals y. But remember, we never write our answer that way. We always write it with the variable first. So your final answer is y equals 9. Okay, so let's review. We have a proportion that contains at least one binomial, meaning that you have a term separated by addition or subtraction. The first step is to protect the term with our parentheses. Our second step is to cross multiply. So we have 8 times 3 equaling 4 parentheses y minus 3. We then must distribute. So we distributed the 4 and we got that. And then our last step, which I forgot to write down, is really just to solve. So we solve by getting our variables on one side and our numbers on the other. All my variables are on the right, so I just have to worry about what's bothering it. Well, the negative 12 is bothering it, so I'm going to do the opposite. Add 12 to both sides. I get 36 equal 4y. 4 is now bothering the y. I do the opposite again, so I divide by 4, and we get 9 equals y. But since we never write it like that, we now get y to equal 9. Okay? All right. Again, if you need to pause for you to write all this down, feel free, but I'm about to erase, so you might want to hit pause now. All right, so example number 2. Ooh, this is a good one. 5 equals 4 minus 3y over 5. Okay? Well, you're going to say, wait a minute, this isn't a proportion because it's technically not a fraction equaling a fraction. But it really is, because I can always add a 1 underneath a whole number. I can always change that into a fraction. So that's what I'm going to do. It really is 5 over 1 equals this fraction. And now I'm going to follow my steps. I'm going to protect my binomial by putting parentheses around it. And then I'm going to butterfly it up. So I get 1 parentheses 4 minus 3y equals 5 times 5. Now what's really nice is distributing this 1, 1 times anything doesn't change anything. So really it's just 4 minus 3y equals 25. So I've cross multiplied. Let me circle the 5 times the 5. I've distributed, and now I need to solve. All my variables are together on the left, so I'm going to subtract the 4 to get it on the opposite side. So I get negative 3y equals 21. Now what's bothering the y? The negative 3. And it's multiplication that's occurring, so I'm going to divide by negative 3. Now be careful of your signs here, because this is a positive 21. What's a positive divided by a negative? Positive divided by a negative is a negative. So I get negative 7. Y equals negative 7. So again, to review, originally we were just given this problem. But it's not a proportion, but we can make it a proportion by just putting a 1 underneath a whole number. And that allowed me to cross multiply. But first I needed to protect my binomial by putting parentheses around it so that when I cross multiplied I could distribute. I distributed the 1 and I got 4 minus 3y equals 25. Since my variables were together on the left, I moved my numbers to the right and I did the opposite. So since this is positive, I subtracted 4. which gave me negative 3y equals positive 21. What was bothering the y? The negative 3. So you divide, because you always do the opposite. You divide by the negative 3, and I got y to equal negative 7. Okay, we're going to do one more for your notes, and then we're going to call it quits, and that will be the end of this session. All right, example 3. I'm going to see if I can find one which we have two binomials. Oh, and here's where the fun begins. Here we go, sir. 4x plus 12 over 8 equals x plus 3 over 2. Okay, do you agree that we have a proportion here, that we have a fraction equaling a fraction? So I don't have to put any indivisible ones. However, my first step is to protect the terms, to protect my binomials. So I put parentheses here and here. So now when I cross multiply, I get 8 times parentheses x plus 3 equals, and when I cross multiply here, 2 times parentheses 4x plus 12. So now I've done my cross multiplication. What's next? I need to distribute. So that means that the 8 is going to the x and the 3. So I get 8x plus 24 equals, I now need to distribute that 2. So I get 8x plus 24. This is going to be interesting. We've seen something like this. Now remember, you always want to combine your variables first. So I'm going to subtract the 8x. And they cancel. What am I left with? Always bring your numbers down. They don't just disappear. I'm left with 24 equaling 24. Is this a true statement? It is. 24 will always equal 24. So I'm going to put a check by it saying that it's true. So my solution, when all my variables disappear, is all real numbers. That is your solution. Okay, to review one more time. We had a proportion where we had two binomials. No big deal. We just protected them both by putting parentheses around them. We cross-multiplied using the butterfly. And when we got down here, we were really careful and we distributed them to both terms within my binomial. I got 8x plus 24 equals 8x plus 24. We always want to combine our variables first because if they disappear, I want to know sooner rather than later. So we subtracted 8x. Sure enough, they disappeared, which means we have a special case. Either it's all real numbers or no solution. But because I have a true statement, because 24 equals 24, my solution is all real numbers. Any questions? Go ahead, write questions at the end of your notes, and we'll go over them tomorrow. And hopefully everything went well, and I will see you tomorrow. Have a good night.